Now, let's go to our next topic, which is rewriting the quadratic function from f of x is equals to ax squared plus bx plus c to f of x is equals to a times x minus h squared k, and vice versa. The equation for a parabola is usually written as, in standard form, ax squared plus bx plus c, where a, b, and c are constant. This is the form displayed in both the VPython parabola and Excel parabola programs. To make the movement of the curve, use also the vertex form. With the vertex form is y is equals to a times x minus h squared plus k, where the point h and k is the location of the vertex of the parabola. In translating between two forms of the equation, you have to rewrite them. Start expanding the vertex form. The vertex form is y is equals to a times x minus h squared plus k. It will become y is equals to a times it will become y is equals to a times x minus h times x minus h plus k. Multiplied out to get now distribute the a. Y is equals to ax squared minus 2ahk Now, it will become y is equals to ax squared minus 2axh plus ah squared plus k. This equation has the same form as y is equals to ax squared plus bx plus c. Now, let's proceed. Let's go to our next topic, which is vertex to standard form. A is equals to a. B is equals to negative 2ah. C is equals to h squared plus k. And we can rearrange these equations to go to other way to find the vertex form to standard. Example, P of x is equals to x minus 1 squared minus 2. We will rewrite this to standard form. So, it will become x squared minus 2x plus 1 minus 2. So, the final answer is x squared minus 2x minus 1. We get negative 1 because of 1 minus 2. Now, let's go to the next topic, which is standard to vertex form. A is equals to a, h is equals to negative b all over 2a, and k is equals to c minus a, h squared equals c minus b squared all over 4a. Example, 2x squared plus 16x plus 33. First, factor out all common monomial factor, which is 2. So it will become 2 times x squared plus 8x plus blank plus 33. We will look for the third term. We can find it by dividing 8 to 2. So it will become 2 times x squared plus 8x plus 16 plus 33. We should deduct something from 33, which is 16 times 2. So it will become minus 32. It will become 2 times x squared plus 8x plus 16 plus 1. So the final answer is 2 times x plus 4 squared plus 1. We get x plus 4 because we find the square root of x squared, which is the x. Then we copy the sign of the second term, which is positive. So it becomes plus. Then we look for the square root of 16, which is 4. So the final answer is 2 times x plus 4 squared plus 1. Now let's go to the next topic, which is standard to vertex form. A is equals to A, H is equals to negative B all over 2A, and K is equals to C minus A, H squared equals C minus B squared all over 4A. Example: 2x squared plus 16x plus 33. First, factor out all common monomial factor, which is 2. So it will become 2 times x squared plus 8x plus blank plus 33. We will look for the third term. We can find it by dividing 8 to 2. So it will become 2 times x squared plus 8x plus 16 plus 33. We should deduct something from 33, which is 16 times 2. So it will become minus 32. It will become 2 times x squared plus 8x plus 16 plus 1. So the final answer is 2 times x plus 4 squared plus 1. We get x plus 4 because we find the square root of x squared, which is the x. Then we copy the sign of the second term, which is positive. So it becomes plus. Then we look for the square root of 16, which is 4. So the final answer is 2 times x plus 4 squared plus 1. Now, if we conclude in this topic, in sum, you can write the standard equation for a parabola as standard form. The standard form is y is equals to ax squared plus bx plus c. Or we can write it as y is equals to ax squared minus 2ahx plus ah squared plus k. And you can write the equation for the same parabola in the vertex form as vertex form. The vertex form is y is equals to a times x minus h squared plus k. Or a times x minus negative b all over 2a plus c minus b squared all over 4a. let us tackle graphing quadratic functions. From the graph of quadratic functions, many properties of the quadratic functions can be read. Example number 1. Graph the simplest quadratic function y equals x squared. First, let us construct a table of values for x and y. Now, let us assume that the vertex is 0, 0. We can fill the x and y. We can start by negative 1 for the x and y for positive 1. Negative 2 and then positive 4. Then 3, negative 3 and then positive 9. The other side, let us have positive 1 for x and positive 1 for y. Positive 2 and then positive 4. Positive 3 and then positive 9. There. Then, plot the corresponding points and draw a smooth curve from the leftmost point to the rightmost. Now let us graph. The vertex is supposedly 0, 0. And then, we will go negative 1, positive 1. Then, negative 2, positive 4. And then, negative 3, positive 9. On the other side, we have 1, positive 1. And then, 2, positive 4. And then, 3, positive 9. The graph of y equals x squared is a curve. This curve is called parabola. This is the reason why the quadratic. The demonstration point between these two parts is a point called the vertex of the parabola. The vertex acts as the turning point of the graph of the quadratic function. The vertex is 0, 0. It is the lowest point in the parabola y equals x squared. The parabola is symmetrical with respect to the line that passes through the vertex. This line is called the axis of symmetry. It divides the parabola into two parts so that one part is a reflection of the other part. In other words, if the grid paper containing the parabola is folded along this line of symmetry, the two parts will fit on top of each other. The axis of symmetry y equals x squared is line x equals 0. Now, let's go to the example number 2. We have f of x is equals to x squared minus 4x plus 4. The solution is and now we will get the ABC of this function. The A is 1 and the B is negative 4 and the C is positive 4. Now, we will use the vertex formula. The vertex formula is H equals to negative P all over 2A. And now we will substitute this. We have B, so negative 4 all over 2. The A is 1, so we will substitute A with 1. And the answer will be 2. And for the K, we have the formula for AC minus B squared all over 4A. Now we will substitute 4 times 1 times 4 minus negative 4 squared all over 4 times 1. And the answer will be 0. Now, 4 times 1 equals 4. 4 times 4 minus negative 16. And 4 times 4, 16 minus 16 over 4. Now we will have 0 all over 4. Equals 0. Thus, the vertex is at 2. 0. And the axis of symmetry in the line is x equals 2. Now, find some representative points. Plot them and draw a smooth curve from the leftmost point of the right to the rightmost point. Now we will have negative 2, 16, negative 1, 9, 0, positive 4, 1, positive 1, 2, 0, then 3, positive 1, 4, positive 4, 5, positive 9, 6, positive 16. Now let us graph that. table of values. For x, we have -2, -1, 0, +1, +2, +3, +4, +5, and +6. For the y, we have +16, +9, +4, +1, 0, +1, +4, +9, and +16. Now, let us graph it. Let us graph 2 and 0. Next, 1, +1. Now, 0 and 4. And then -1, +9. -2, and +16. On the right side, 3, +1. 4 and +4. 5 and 9. +6 and 16. The graph shows that the ranges is f of x is greater than equal 0.
The next topic is changes in A, H, and K. It is interesting to note that the value of A in the quadratic function f of x equals ax squared plus bx plus c, plays in the important role in the opening of the parabola. Example, g of x equals 3x squared. A equals 3. Since a equals 3 greater than 0, the parabola opens upward, and since the absolute value of a negative equal 3 greater than 1, its graph is narrower than the graph of f of x equals x squared. Other explanation. H of x equals -4x squared minus 2x plus 1. A equals -4. Since a equal -4 less than 0, the parabola opens downward. The the absolute equals 4 greater than 1. Its graph is narrower than the graph of f of x equals x squared.
proceed to the next topic, the series of quadratic function. The parabolic structure allows the graph of a quadratic function to intersect the x-axis in different ways, as it's shown. It may cross the x-axis once, like this drawing, twice, or not at all. If the parabola intersects the x-axis, the ordinate of the point or points of intersection is 0. This is why the abscissas of the point of intersection of the parabola and the x-axis where the ordinate is 0 are called the zeros of the quadratic function. The primary concern in finding the zeros of the quadratic function f of x is equal to ax squared plus bx plus c is to find values of x such that f of x equals 0. In other words, the zeros of f of x are the solutions to the equation of ax squared plus bx plus c equals 0. There are 4 ways using factor techniques. For example, f of x is equal to x squared equals x. The a is equal to 1. The b is equal to 1. The c is equal to 0. Equating f of x to 0. x squared minus x equals 0. The common monomial factoring. X is times the x minus 1 equals 0. The answer is x is equal to 0 or x is equal to 1. The zeros of f of x are 0 and 1. The vertex of the parabola is the axis of the symmetry is x equals 1/2. The parabola opens upward or f of x crosses the x-axis twice. Imaginary zeros. Recall that if a quadratic equation cannot be solved by factoring, an alternative way is to make use of the method of completing the square. In this case, there is a possibility that the quadratic equation has no real root. A non-real number is called imaginary number. The unit imaginary number is denoted by imaginary or I symbol, and is defined as follows. For example, square root of 25 equals square root of 25 times negative 1 equals square root of 25 square root of minus of negative 1 equals 5 imaginary. Square root of 12 equals square root of 12 times negative 1 equals square root of 12 square root of negative 1 equals 2 imaginary or square root of 3. Next, square root of 11 negative 11 equals square root of times the 11 times negative 1 equals square root of 11 or square root of negative 1 equals imaginary line or square root of 11. In using the method of completing the square, for example, h of x is equal to negative x squared minus 2x minus 2. H of x is equated to 0. Negative x squared minus 2x minus 2 is equal to 0. Both sides are multiplied by negative 1. X squared plus 2x plus 2 equals 0. Negative 2 is subtracted from both sides. X squared plus 2x equals negative 2. 1 is added to both sides. X squared plus 2x plus 1 is equal to negative 2 plus 1. The left side is factored. The quantity of x plus 1 squared is equal to negative 1. Square root of both sides is extracted. Square root of the quantity of x plus 1 squared is equal to plus positive or negative square root of negative 1. Definition of an imaginary number. X plus 1 is equal to positive or negative imaginary number. The zeros of h of x are negative 1 or positive or negative imaginary number. Using the quadratic function, an alternative way of finding the zeros of the quadratic function is through the use of the quadratic function. Suppose f of x is equal to ax squared plus bx plus c. Its zeros can be determined by solving the equation x squared plus bx plus c equals 0 using the method of completing the square. For example, f of x is equal to 12x squared plus 23x plus 5. Next, 12 of x squared plus 23x plus 5 is equal to 0. The A is 12. The B is equal to 23. And C is equal to 5. Next, first, x is equal to negative b positive or negative square root of b squared minus 4ac over 2a. Write the formula. Negative 23 positive or negative square root of 23 squared minus 4, the quantity of 12 times 5 over 2 times 12. Next, negative 23 positive or negative square root of 529 minus 240 over 24. Next step is negative 23 positive or negative 17 all over 24. Yes, last x sub 1 is equal to negative 23 plus 17 all over 24 equals negative 6 all over 24 is equal to negative 1/4 or x sub 2 is equal to negative 23 minus 17 all over 24 equals negative 40 all over 24 is equal to negative 5 all over 3. The zeros of f of x are 1/4 and negative 5 all over 3.
Now let's move on to the topic number 9, roots of quadratic function. In this section, we will learn how to find the roots of quadratic equation. Roots are also called x-intercept or zeros. A quadratic function is graphically represented by a parabola with vertex located at the origin, below the x-axis, or above the x-axis. Therefore, a quadratic functions may have 1, 2, or 0 roots. When we are asked to solve a quadratic equation, we are really being asked to find the roots. We have already seen that completing the square is a useful method to solve quadratic equations. Thus, this method can be used to derive the quadratic formula, which is used to solve quadratic equations. In fact, the roots of function f of x is equal to ax squared plus bx plus c are given by the quadratic formula. The roots of a function are the x-intercept. By definition, their coordinate of points lying on the x-axis is 0. Therefore, to find the roots of a quadratic function, we set f of x is equals to 0 and solve the equation ax squared plus bx plus c is equals to 0. We can do this by completing the square as ax squared plus bx is equals to negative c. X squared plus b over ax is equals to negative c over a, where x squared plus b over a plus b over 2a squared is equals to negative c over a plus b over a by 2a squared. X plus b over 2a squared is equals to negative c over a plus b squared over 4a squared. X plus b over 2a is equals to plus minus square root of negative 6 of c over a plus b squared over 4a squared. For a squared. Solving for x and simplifying, we have x is equals to negative b over 2a plus minus square root of negative c over a plus b squared over 4a squared. X is equals to negative b over 2a plus minus square root of negative 4 ac over 4a squared. 4a squared. X is equals to negative b over 2a plus minus square root of b squared minus 4ac over 4a squared. X is equals to negative b over 2a plus minus square root of b squared minus 4ac over square root of 4a squared. X is equals to negative b over 2a plus minus square root of b squared minus 4ac over 2a. Then x is equals to negative b plus minus square root of b squared minus 4ac over 2a. Thus, the roots of a quadratic function are given by x is equals to negative b plus minus square root of b squared minus 4ac over 2a. This formula is called the quadratic formula, and its derivation is included so that you can see where it comes from. We call the term b squared minus 4ac the discriminant. The discriminant is important because it tells you how many roots of a quadratic function has, especially if b squared, if 1 b squared minus 4 ac is less than 0, there are no real roots. No real roots. B squared, number 2, b squared minus 4ac is equals to 0. There is a 1 real root. Number 3, b squared minus 4ac is greater than 0. There are 2 real roots. We will examine each cases individually. Case number 1. No real roots. If the discriminant of a quadratic function is less than 0, that function has no real roots. And the parabola it represents does not intersect the x-axis. Since the quadratic formula requires taking the square root of the discriminant, a negative discriminant creates a problem because the square root of negative number is not defined over the real line. An example of quadratic function with no real roots is given by f of x is equals to x squared minus 3x plus 4, where a is equals to 1, b is equals to 3, negative 3, c is equals to 4. Negative 3 squared minus 4 times 1 times 4 is equals to 9 minus 16. Final answer is negative 7. Notice that the discriminant of f of x is negative. This function is graphically represented by a parabola that opens upward, whose vertex lies above the x-axis. Thus, the graph can never intersect the x-axis and has no real roots as shown below. This is an example of the graph number 1. One-wheel root. If the discriminant of a quadratic function is equal to 0, that function has exactly one wheel root and crosses the x-axis at a single point. To see this, we set b squared minus 4ac is equals to 0 in the quadratic formula to get x is equals to negative b plus minus squared of 0 over 2a is equals to negative b over 2a. Notice that x is equals to negative b over 2a is the coordinate of the vertex of the parabola. Thus, a parabola has exactly one wheel root. When the vertex of the parabola lies right on the x-axis, the simplest example of a quadratic function that has only one wheel root is y is equals to x squared, where the real root is equals to x equals to 0. Another example of a quadratic function with one wheel root is given by f of x is equals to negative 4x squared plus 12x minus 9, where a is equals to negative 4, b is equals to 12, c is equals to 9. Notice that the discriminant of f of x is equals to 0. b squared minus 4ac is equals to 0. So, 12 squared minus 4 times negative 4 times 9 is equals to 144 minus 4 times negative 36 is equals to 144 minus 144 is equals to 0. This function is graphically represented by a parabola that opens downward and has vertex 3 over 2, 0 lying on the x-axis. Thus, the graph intersects the x-axis at exactly 1 point. This is an example of a graph of a one-wheel root. It has the vertex is lying at the x-axis at exactly 1 point.
Imaginary zeros. Recall that if a quadratic equation cannot be solved by factoring, an alternative way
Thank you for those who watched this video, for those who like this, and for those who spread this. I hope you learned something from it, and God bless all of you. And don't give up on math. We can do this.